and contributing to the development of Earth and humanity. Bring space closer. QPS-SAR.
We are looking forward to adding another IQPS satellite to space on today's mission and thankful to the team for their patience in getting to the launch pad.
Today's mission is our first launch after a 3-month hiatus following our September 19th anomaly. In the time since, our anomaly investigation has determined that the most probable cause of the rocket failing was a highly complex set of conditions that allowed an unexpected electrical arc to occur within the second stage's power supply system. Our team's top priority has been to find a way to mitigate this concern. They investigated not only the root cause of the anomaly, but any other vulnerabilities across Electron. As a result, there are a couple of key corrective measures and changes that have been applied to today's and all future Electrons to make our launch vehicle that much more reliable.
That's right, we have improved our pre-flight vacuum testing regime with new instruments implemented in the pre-flight tests, both at the component level and the stage level, that can sense partial energy discharge right down to the picocoulomb. We've also sealed up the battery frame on the second stage that contains all of the high voltage connections and equipment and pressurized it down to about 0.5 psi for launch. That's why our view from the camera above the battery frame will look a little bit different if you've followed along with enough of our missions to spot the difference. It's important to remember, though, that overall we have had 37 successful orbital missions to place 171 satellites in orbit. And the past 2 years had been a flawless record of 20 successful missions, one after the other. So we can't wait for today's return to service to add to that satellite tally once again.
Absolutely, but right now we are only 12 minutes away from liftoff, and you know what that means. Up next, we have our Go No Go poll, where our operators in Mission Control give a status report on their systems to confirm whether or not we will proceed with the count. Let's listen into Mission Control and check in on how we're tracking for launch.
We're at T-minus 12 minutes at holding.
And all stations LD on mission, just a reminder that we've entered a hold at T-minus 12 minutes. Just working on bringing a couple final values within bounds, and we will be resuming the count shortly.
All right.
From Mission Control, you might have heard there that they called out for a hold in the launch countdown. Now, our launch operators can call a hold at any point in the countdown if they notice anything unusual about the rocket before liftoff. What that means is that we've paused the clock at T-minus 12 minutes to give mission control time to take a look at the data and see what has raised that red flag.
Stay with us on the broadcast, though, as we'll keep up the comms channel to mission control up, so with that we can listen out for some updates.
There's some live sound of Electron as it's getting ready for its first ever integrated flight, or first integrated flight test in about a couple of months. Sorry about that, I had a couple of difficulties with my camera, but we're back in progress. We're back in business, and you see some live views of Electron on the pad at T-minus 12 minutes and holding. You can hear some venting coming from Electron. There's a view of mission control. They are the people who are controlling this rocket for today's launch, and they'll be given the final directions and polls for this launch.
All stations LD on mission. This time we're going to be resuming the count imminently. Please be prepared for the go, no-go poll. We'll get straight into that as the count resumes, but please raise any issues you foresee immediately.
There you can see a view of the TE. Going back to the supervised. We're going to be unholding in a couple of seconds to minutes as we get ready for this launch.
And all stations, the count has been resumed. Right. We'll be proceeding straight into the go, no-go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
VCon.
VCon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
RF.
RF is go.
MM.
MM is go.
LD Shadow.
LD Shadow is go.
LD Sup.
LD Sup is go.
Okay, all stations, the go, no-go sequence is complete. We are T-minus 11 minutes and 8 seconds and counting. We are go for terminal count at T-minus 10 minutes, and from this time, the 3-word hold procedure is in effect.
This is amazing news.
That was Mission Control reporting Electron systems and the IQPS payload on board are confirmed healthy and good to go for an on-time launch. The range is ready to support. The weather continues to look good for liftoff at 5:05 local time or 4:05 a.m. UTC.
Amazing to see Electron still doing well and still getting ready for its first integrated flight test and its last flight test of this year. This will be the last flight of this year. Surprisingly, if this is the first in a while, so this will be the last launch of this year. Electron will be doing a launch in January. So don't expect the Electron launch this month. Again, this will be the last one. And we're past T-minus 10 minutes and holding, or past holding, the holding point, and we're now going through with
Today's
count.
mission is heading to a 575 kilometre circular Earth orbit at a 42-degree inclination to add IQPS's next SAR satellite to its growing smallsat constellation. With its constellation, IQPS is aiming for frequent Earth observation day and night that can contribute to social issues such as disaster prevention, defence and environmental research. Here's more from the IQPS team.
Our company IQPS is developing small SAR satellite QPSR in Fukuoka, which is located in Kyushu, Japan, and currently operating 3 satellites. The Kyushu, this region has a good environment with the rocket launch facilities, a history of high quality manufacturing in industries like automobiles, and educational opportunities in space engineering. Our founder established IQPS in Kyushu with a mission to develop the space industry in this region, and we have carried on that mission by launching QPSR project in Kyushu and advancing the construction of a satellite constellation. Looking beyond that, our vision is to make Japan the birthplace of space innovation from Kyushu and to free people from anxiety and support their daily lives through satellite. The launch by Electron into our dedicated orbit is a strong tailwind towards the realization of our vision. So we are very excited with local government and partner companies in Fukuoka who has been cooperating with us.
Currently, QPSR provides world-class high resolution and high image quality, enabling us to observe the Earth at 46 centimeter resolution. Our future plan is to launch a total of 36 satellites, ultimately aiming to provide near real-time observations at around 10-minute intervals. By utilizing this high-frequency, high-resolution data, we envision contributing to the disaster management, infrastructure monitoring, and creating safe, secure communities in everyday life. Furthermore, after these global-scale data are accumulated and combined and analyzed with other valuable data, we think we will be able to foresee the future one step ahead. And by being able to see a step-ahead future, we believe we can liberate people from uncertainty and make people's life more efficient and productive, such as avoiding traffic jam, escaping from disaster, and estimating the economy. Still, there's a long way to go to achieve this, but we hope one day our data will become the backbone to foster a new, sustainable, and valuable environment for the world. It was this early April when we asked Rocket Lab if there's an available launch spot for our satellite. On behalf of IQPS, I would like to appreciate to all the Rocket Lab members for the hard work in making our satellite be launched in this revolutionary short period. Thank you very much. ありがとうございます。
We are thrilled to be launching IQPS on Electron's 42nd mission today. Now, this mission is our 10th launch for the year so far, making 2023 our busiest launch year to date. Now, as we wait for liftoff, let's take a closer look at the numbers behind Electron launches.
Welcome to Electron by the Numbers. Electron first took to the skies in 2017, and today we've launched 41 Electron rockets and counting. Electron's first stage is powered by 9 3D printed Rutherford engines, while the second stage has just one vacuum-optimized Rutherford engine. To date, we've launched 409 Rutherford engines to space. Why not 410? Well, recently, we reflew a Rutherford engine to space for the first time after recovering it on a previous mission. So this hard-working engine has done double duty. But Rutherford isn't the only type of engine on Electron. There's a single small but critical engine on Electron's kick stage called Curie. This reliable engine is used to circularize our orbit for payload deployment and can perform multiple burns to deploy multiple payloads to different orbits on the same mission. Electron launches from 3 pads. 2 are located at our private orbital launch site in New Zealand, and a third in Wallops, Virginia. So far, we've launched 38 missions from Launch Complex 1 and 3 from Launch Complex 2, with more coming up. It takes Electron roughly 9 minutes to go from liftoff to orbit, reaching speeds of up to 27,000 kilometers per hour along the way. At liftoff, Electron weighs about 13,000 kilograms, and around 12,000 kilograms of that is liquid oxygen and kerosene. More than 170 satellites have been successfully deployed to orbit by Electron, usually to an orbit between 500 and 1,200 kilometers, but sometimes all the way to the moon. And behind it all stands a dedicated team of hundreds of engineers, technicians, operators, and supporting team members who make Electron one of the world's leading launch vehicles.
T-minus 4 minutes and 10 seconds.
It's easy to forget to stop and smell the roses, but it is amazing to see those numbers.
Now back on the pad, we are tracking no issues with the launch vehicle. IQPS's payload remains healthy and the weather is looking green for an on-time launch. So here's what you can expect next. At T-minus 2 minutes, the flight computer on Electron will take over the launch countdown. Then at T-minus 1 minute, 30 seconds, we should hear the call that LOX loading is complete on Electron.
Shortly after that, at T-minus 1 minute, we can expect confirmation that the launch vehicle's first and second stages are pressurized for launch, followed by the final countdown to liftoff at T-minus 10 seconds. Let's hand over now to Mission Control.
All right, Electron is coming back to life, and next year, Electron returns to normal after this. Electron will not be normal this year, for this year being, because it's not going to do any more launches for this year, so don't expect...
All stations, LD on mission. From now on, there should be no red flags in your critical LCCs. Beacon, LD mission.
LD Beacon.
Lock auto sequence and confirm.
Confirmed, locked.
And please confirm all expected primary flight computer ASGOs are green.
Confirmed, all ASGOs are green.
And all stations, we are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
Ooh, yes! We love to hear that sound. We love to hear the words for go for launch. Those are the magic words for a rocket to go up. And that means, currently, right now, Electron is planned to lift off about 10:04 p.m. EST. We're at T-minus 10 minutes and 10 seconds. This will be a historical moment for Electron because it has some redesigns to it since they had an anomaly with
Avionics batteries have switched to internal power. Ground power is disabled, vehicle is fully on internal power.
Alright.
AFTS is green and enabled for flight.
We're coming up on the final minutes of Electron. This will be the final time it sits on this pad, and it will lift off in about 1 minute and 30 seconds from now. I've been waiting a while for Electron.
Lock load is complete.
This is my
System
first,
is in recirculation.
This is my first Electron of the year, and will be the last Electron launch I do this year. I'm proud to see this rocket go up for the first time for my time.
Anti-geysering is disabled.
We're at T-minus 1 minute and 5 seconds away from liftoff, and we should get the final go for launch at 45 to 40 seconds, and we are on internal power. Our Electron is on its own internal power.
Stage 1 and Stage 2 tanks are pressed.
Alright. We're pressed for flight. Are we go
High
for...
flow engine purge enabled.
We should be go... Okay, I guess we already are go for launch, because the launch director said we are go for launch. Let's sit back and watch Electron go back to its original formation. T-minus 30 seconds.
T-minus 20 seconds and counting.
Oh my god! Oh my gosh! Oh! T-minus 10 seconds!
10, 9, 8,
Oh!
7, 6, 5,
10,
4, 3, 2,
please.
1.
Oh!
Lift off.
Lift off! Go Electron! Go, go, go! Go fly high, Electron, go fly high. Godspeed. There we go. Electron's back to normal. He is now pitching downrange. There's some amazing views of Electron going up for the first time in a couple of months after
Electron has lifted off from Launch Complex 1 and we are 34 seconds into our flight. With Electron now clear of the pad, soon we will approach max Q, or maximum aerodynamic pressure, the moment of the most amount of stress against the rocket. So let's listen in for the call from Mission Control that Electron has passed max Q.
We should be passing through max Q, like she says.
Vehicle supersonic, approaching max Q.
Yeah!
High voltage discharge, nominal.
Yeah!
Cleared max Q.
The main event we're wanting to see here.
And there you have
is
it.
station-
Electron has cleared max Q. A beautiful and nominal mission so far. Now up 15 kilometers in altitude as the rocket reaches speeds of more than 2,100 kilometers.
Next up are 3 mission milestones that happen in quick succession. First up, we have MECO, or main engine cutoff. This is when all 9 Rutherford engines on the first stage throttle down and then shut off completely. Very quickly after that, we have the separation of the first and second stages, and you'll see that main booster tank fall away from Electron's second stage. We then have the ignition of the single Rutherford engine on Electron's second stage, as the mission continues to orbit. Those calls should be coming up from our operators in mission control very shortly.
Now at stage separation, we need to know if stage separation works. And that's where the anomaly happened. The Rutherford vacuum engine is designed differently this time. It might look a little bit
Stage 1
different.
propulsion holding nominal. Stand by for MECO in roughly 30 seconds.
They had an anomaly. They had a problem with the engine, it had a spark, and it went off course or blew up. And the main event,
15 seconds to MECO.
this is going to be a big moment.
Entered burnout detect mode.
Staging will be the most best moment and the most critical opponent of this mission.
MECO confirmed.
MECO, main engine cut off. We should get a camera view. Oh my gosh.
Stage separation successful.
Engine ignition.
Stage 2 ignition confirmed.
Stage 2. Stage 2 is back. Stage 2 is finally done. Stage 2 is confirmed.
As you can probably tell from that applause, we have had a successful MECO, stage separation and second stage engine start for Electron. Up next will be the fairing jettison, where the 2 halves of Electron's protective fairing split and fall away from the vehicle to expose IQPS's satellite to space in preparation for payload deployment. Now we might see those 2 halves on screen too as we clear that next milestone.
Fairing jettison succeeded.
That was them there on your screen. Electron's fairing halves have fallen away as planned. At 3 minutes
Stage two
and
propulsion
42
still holding
seconds
nominal.
into the mission, the single Rutherford engine on Electron's second stage continues to burn bright as we make our way to orbit.
High voltage battery
We have a
discharge
new
nominal.
view of the engine's nozzle that includes a nitrogen bottle that you can see on the top left of your screen, which has been introduced as part of an update to the second stage system. Now, this is providing pressurized gas to the enclosure covering the second stage electrical system, helping to minimize the chances of electrical arcs.
Stage 2 propulsion nominal.
Soon we'll reach a mission milestone unique to Electron, the battery hot swap. Electron's fuel pumps are battery powered, and once we deplete the first set of batteries, they're of no use to us anymore. And so we swap them out with a fresh set, ejecting the depleted ones so that they don't hitch a ride to orbit. That milestone should be coming up at around 6 minutes and 43 seconds into the mission, and so we have a while to wait for that milestone just yet.
Ooh. Y'all, that is the most beautiful
We are
thing.
now 4 minutes and 42
That'll be
seconds into
ended
flight and well on our way to
coverage.
orbit. So far, we have successfully lifted off, cleared the pad, and passed.
Thank y'all so much for watching. From now, Starlink 7-9 is going to be launching. Thank y'all for watching. I'll see you on Starlink 7-9, which will be my first Vandenberg live launch. This will be one of the two. This will be of the second first for this channel. Thanks for watching and have a good day.